Hi everyone! In this tutorial we are going to learn how to use optical flow to control our fluid simulation. This technique can be used in different simulations like particles, fluids or smoke. Before we start, I want to say this tutorial is a follow-up from the original one from Mark Fancher. Big thanks to him for making this awesome video about optical flow, where he is emitting fluids from the footage and using optical flow to control its velocity. On this tutorial, we are going to explore a similar workflow, but instead of emitting fluids, we are going to use the optical flow to control a flip tank like this Houdini example. Okay, let's begin with the concept of our project. As you may know, optical flow allows us to get motion vectors from the footage. So we are starting by importing our image sequence using CopNet. Then we are going to get our motion vectors from optical flow and edit the force or length of those vectors. And to finish this process, we are going to convert the result to a volume so we can use in any simulation. After we finish this process, we are going to prepare our fluid simulation with a flip tank and use that volume to control our fluids. Sounds easy, right? So let's begin. Okay, let's start by placing a geonode and call it footage. Dive in. And as I said, we are going to use Cop2 network to import our image sequence. Okay? Let's place a file. And I'm going to import my sequence. That is a fire animation. Okay? I'm going to change the file size to half, you don't need, but I'm going to do that for now because to see our preview a little bit faster. Okay, on Cop2 network we are going to change a method from mesh to volume slice. Because on optical flow we need to work with volumes. Okay, let's place a transform just to edit our volume. Let's rotate 90 degrees, minus 90. Okay, and I'm going to change the scale to 4 just to have a little bigger volume. Okay, from -2 to 2. So we know the width of this, let's call it plane, of this image sequence is going to be 4, the width. Okay, and let's place the optical flow, volume optical flow. So this node needs two inputs. The first one is our current frame, for now the number 80. And the second input, it's the goal image, and for that we are going to use a time shift. Let's wire this and this to the second input. And on this time shift we are going to change, instead of using the current frame, we are going to use the next frame. Let's place a +2. You can play with this. For example, now we are going to use as a second input this one. Okay, this frame. Let's go to the first so we can explain a little better. So this optical flow, the first input is getting the first frame, and second input is getting the third frame. Because the optical flow needs to compare frames to get the motion vectors, right? My animation is kind of slow motion, that's why I'm changing this one. On the skate animation with that slow motion, I use up to 5 frames, so you can get a little better the motion vectors. Okay, but for this example, let's use the +2. So now we have a volume. We don't see much, but if you press on I, you see different volumes. And let's place a volume slice. Okay. One thing I forgot. We changed this method to volume slice instead of mesh because the volume optical flow needs volumes to work as in inputs. Okay. And in on volume slice we need to change one thing. Instead of using a mesh, I want to use points. Okay. As you see, I'm going back to mesh just to see what we are getting. As you see, we have colors now on our plane. And those colors are the motion vectors I was talking about. So the thing we are going to use is to use a wrangle. There is points, okay? And we are going to convert those colors to a new vector called v. That will be our velocity, okay? Let's name this wrangle, convert cd to v, okay? And we have now a lot of points. Some of them are black, and those points we don't need to be processing every frame, okay? So let's delete those black points. So let's place another point wrangle. Let's call it delete black points. And we are going to use the brightness or the luminance of each point to delete them. So let's create a channel called thresh. It is a channel float called threshold. So you can control with a slider, okay? And let's place a statement using the luminance. In other tutorials, I used to convert RGB to AHV and then use the value as brightness. But now we can use this luminance function. And I'm going to use the V instead of the color because we know those motion vectors are kind of like colors. So, right? So we can use these. Instead of you could use CD, of course, but for now let's use the velocity because they are the same. And if that luminance value is less or lower than our thresh, let's wrong bracket. Okay, why can't I? My computer is trolling me. I'm sorry about that. Let's remove the point. 0, point none. See, so now we have a slider to control our removing points, our threshold. Let me just edit this interface because I want this to be lower, so we have more control on this slider, okay? Nothing about 001, yeah, okay. To explain you why we are using this V is because if you want, instead of seeing motion vectors, if you want to see the original color, let's place a convert volume slice again, sorry. Volume slice, as we did. Instead of mesh, we are using points. And we can use attribute copy. Oops, sorry. And we can do this, sorry. Damn, I'm missing all the wires. Okay, I'm going to to copy the V, and now we are seeing the original footage, the original colors of our footage. Of course, we are only seeing some of the pixels. We are missing this fire, for example, because this fire doesn't have any motion vectors. Okay. We are deleting the points or the pixels that don't have motion vectors, okay? Now we are deleting, and we need another thing, is that we need to edit the force of our vectors, right? Our velocity, or multiply velocity, okay? Let me see if I can show you. They are really small. They are here. I know you can see, but let's start our expression. So I'm creating a vector that it is equal to v. So we are copying the vector v to a new vector val. Let's, oops, it has flowed, not a force, a multiplier, and it will be a channel float multiplier force. And if I press this little icon, now we have a slider, right? And let's update our v vector with a multiplier times this times val. Okay, if I increase this to 10, and if I press this little icon, now you can see some blue dots. Let me change the background, maybe this will help. Okay, now you can see that light blue vectors, right? Those are the motion vectors now as v. Okay, I increase this to 50, maybe you can see a little better. Change frame, and as you see, now we have motion vectors as v vectors. Okay, everything is cool. You see our velocity vectors, and those vectors will control our fluid simulation. Let's just place a null just to be a breakpoint. Let's call out velocity. And as I said, now we need to convert this result to a volume, right? So let's make a VDB from particles. Let me turn off this little icon. I'm going to change the voxel size to 0.1. It is going to take a while. Point radius 0.1, and this is going to be 0.01. Okay, and we need to do one more thing. If you see our VDB, if press I, we just have a surface volume, and we need to pass the velocity volume so we can use on our fluid simulation. So here on point attributes, let's click on plus, and let's pass the v, the vectors, to a new volume called val. Sorry, I have the caps lock. It has to be the val with small caps, small letters. Okay. Now, if you check on I, you see now we have a new volume called val. That is the velocity that we need. A volume containing all the velocities we need. And let's place a null and call it out volume. Sorry, I'm missing a lot of keys while typing. Okay, so just check this out. We are importing the image sequence. We are converting that image sequence to motion vectors, pass it to color, convert color to V, deleting the points that don't have any motion vector, and multiplying that motion vector using a slider, okay, just to increase the force of that velocity. After that, we are converting those points to a volume so we can use in any simulation. Okay, so for now, let's prepare our flip tank. Okay, now we have our footage. Everything is prepared. Now let's place our flip tank. Let's come here to these tabs and go to particle fluids, press on flip tank and press enter. So we are going to create a flip tank at the center of our scene. Okay, everything is cool. Let me go up and press L because I need everything in control. So we have the initial flip tank, our dot network, our fluid interior, we don't need that for now, and our fluid tank. This is the final process. So to start, let's go to the initial flip tank initial, just to control the size of our flip tank. Okay, on wave tank, let's change this. We know the width is 4. Let me change this to 1 for now. And let's change this to 4 on Y, and let's change this to 1. Okay, just changing these values. And on Z value, we know that my footage is 16 by 9. So we know this is, let me change this to copy parameter, and I'm going to make a little expression. So the Z value will depend on the X value, okay? So here, I'm just going to do a little math. This times 9 divided by 16. Okay, now I know I have the exact size, the 16 by 9. Because my footage is 16, is full HD, so it is 16 by 9. Okay, and we know that our width is 4 because on the transform on our footage, here on this transform we put 9. Okay, so our flip tank is cool. We have our particles. Everything is on place. Let me check the surface. There, we don't need that. Okay. I was just controlling the flip tank. Now let's go into the dot network. Okay, here we have our flip tank, our flip solver, the gravity, everything else. Okay, if I press play, nothing will happen. Just checking the flip tank particle separation. I'm leaving on 0.75 because if I lower this down, my computer will slow down and the tutorial will be a pain in the ass. So the closed boundaries, everything is alright. And let's import our velocity, our motion vectors to this flip tank. If you see here, on the flip solver, you have 4 inputs. Normally, we connect something to this, the last input, and this will be the sourcing. If you want to emit particles, you connect anything to here, to the 4th input. But in our case, we just want to import velocity, right? So a volume that is going to change this flip tank. And if you check this 3rd input, let me just go here so you can see the subtitles. On the 3rd input, you see it says volume velocity, and this is the input we are going to use. Okay, so let's import our volume that we just created, that VDB, volume source. And first things, let's import on SOP path. Let's pick our out volume inside the footage, out volume, press accept. Why is not picking this up? Okay, out volume, and we need to import that. Remember, we created a volume. Let me just show you. We create a volume called vel. Okay, let's go here, vector, and it's called vel, and the target field will be the velocity of our particles. And now let's wire this to the 3rd input, where the volume velocity. Okay, everything is all right. And if I go up and press play, you'll see our particles will start changing with those motion vectors, right? One thing I know, it is going to work, but it's going to be chaotic. It's because, let me pause and stop the simulation. Remember, I was showing you the vectors here, but right now we have a multiply force way for this to work smoothly. So let's decrease it to 10, maybe lower. I think 10 will be alright. And one thing I want to do is to have my flip tank on the same level as our volume, right? So let's go back here to the wave tank. I know there is a water level here, and let's place, okay, 0.1. So we have our footage a little bit inside the flip tank, okay? I hope you can see that. Just increase the water level. Here you can control where your flip tank starts. 0.1, it works, okay? I did something wrong, okay? Everything is all right now. Let me hide the footage, and you will see that this is going to work. I'm just going to do one thing for now. I'm going to cache this. So let's go inside the flip tank, and I'm not going to use this for now. Sorry, but I don't like you. I'm just connecting this particle fluid surface. Okay, so I'm just going to use particles, the velocity, and we can control the colors of our particles. Let me just simulate a little bit. I'm going to pause the recording just to skip this waiting time. Okay, now, so I have 4 seconds of my animation pre-cache, my simulation, okay? Just to show you how you can paint your particles, your fluid. You can do this 2 ways. If you go to flip tank fluid and use only the surface preview, you can use velocity to change this, okay? Let's decrease the range to maybe 3, 2, 1. Okay, 1 will work, maybe 2 is better. And we are playing with fire, so let's make it like something like this. So the darker one will be black, this will be red, not that red, orange, and yellow, something like that. Okay, and as you see, this is one way to paint your particles. But if you want, we can use the original sequence, right? Remember, we have here this volume slice, okay? And we can place a null, just and call it out colors. And we can use that to paint our fluid, right? So let's go here. Let's merge, object merge, and let's pick that null from inside footage, out colors, okay? So if you see here, we have our points with the original colors from the footage. And let's place attribute transfer, geometry, and this here, and let's color. Okay, so now we have the original colors from our footage. Of course, the density of my fluids are way too small. See, pretty cool. Let's change the background to light, so you can see we are painting the black ones too. Okay, and one thing you need to do is save this to a cache, right? One way I like to do displace a file cache, delete this heap name, because I don't want to use the project name for this for the name of this cache, because I like to save these in different versions. For now it's optical flow _01. If I change it to another version, call it _02, this cache won't work anymore. Other thing I like to do is name it cache fluid color. Okay, now I'm going to press save to disk, but I'm going to stop the recording, and one thing I want to do before that is decrease or increase the resolution of our fluids. So I'm going to decrease this to 0.04. Okay, as you see now I have more particles here, and I'm going to increase the grid scale just to have more bottom. Okay, and I'm going to decrease the frame run just 150 just to have 5 seconds. Okay, I'm going to cache this and pause the recording and be right back. Okay, I just finished my cache with my particle simulation, and I just put a point of ops just to paint our particles, and I did a flipbook so you can see the final result, the preview. So this is the simulation, my flip tank with the optical flow controlling the fluids, and now it's up to you controlling the motion vectors. For example, on footage, control this multiplier force to get better control of your fluids. And one thing I did on my animation is that I had viscosity to the flip scene, so it won't work chaotic as water. I had a little bit of viscosity. Okay, and as you see now we have our fluids being controlled by the footage. Okay, now you know how to control a fluid simulation using a footage. If you want to know how to emit fluids using optical flow, I recommend check out Mark's tutorial. If you like this video, don't forget to hit the subscribe button and check out our Patreon page. With your support, we'll be able to keep doing these tutorials for the community, and during this month we are having a special offer with Houdini digital assets. Don't forget to check it out. Hope you enjoyed this video. Big thanks to Mark Fancher for his tutorial about optical flow, and to all our patrons for the support and awesome feedback. See you on the next one.